R.6, which is simplifying rational expressions, and also some with exponents. So I first need to go through our 3 exponent rules that you should be familiar with. Our first is the quotient rule. If I have an expression divided by another expression where they have the exact same base, in this case they both have an a, with different exponents, you can go ahead and subtract them. So we've become a to the n minus n. That whole quantity is my new exponent. Negative exponents get sent down to the denominator. So a to the negative n would become 1 over a to the n. And then lastly, exponents of 0. Whenever you have an exponent of 0, that just equals 1. 5 to the 0 is just 1. 25 to the 0 is just 1. So let's try some examples using these exponent rules. Example 1a is going to expand for a couple simplifications here. First, I'm going to leave my numerator alone. 4a to the negative 3, b to the 4th, c squared. We'll bring that negative down to the bottom, but first I want to go ahead and take care of this exponent in the denominator that is being transferred for that entire product in my parentheses. So when you have this, you're going to go ahead and distribute that exponent to every term in there, every single term. So I have 2 raised to the negative 2. I have a raised to the negative 2. I have b squared. Now b squared to the negative 2, you're going to go ahead and multiply those exponents there. I get b to the negative 4. Then I have c to the negative 3 raised to the negative 2. Well, we're going to multiply those. We get a positive 6. Negative 3 times negative 2 gives me a positive 6. And then d to the 0 to the negative 2, well, that's still just going to be d to the 0, which we just talked about. D to the 0, I'm going to get rid of that. That's just 1. Just a 1. D to the 0 is just 1. Okay, from here, I'm going to go ahead and move things around. I don't want to leave negative exponents in the bottom. I want to bring them to the top. Negative exponents on the top, same thing, they're going to be brought down to the bottom. So 4, we're going to keep 4 on the top. A to the negative 3, well, that's going to go to the bottom. B to the 4th, that's going to stay on top. C squared stays on top. Now let's go look at our denominator. 2 to the negative 2, that needs to get brought to the top. Now it's 2 squared. A to the negative 2 on the bottom comes up to top. A squared. B to the 4th, that's going to come up to the top. C to the 6th, that's going to stay down on the bottom. And our 1 doesn't change anything, so I'm going to omit that at this point. From here, go ahead and combine any of your like terms. So let's just focus on the top. I have a b to the 4th and another b to the 4th. When I multiply that, I'm going to go ahead and combine. I have b to the 8th. You are now multiplying these. You add your exponents. I have a 4 and a 2 squared. Well, 2 squared is just 4. 4 times 4 gives me a 16. Put that out in front. Then I have a c squared and I have an a squared. Down on the bottom, what do we have? A cubed and c to the 6th. I can't combine any of that. Now let's look top and bottom. What can we cancel out from there? My 16 is just going to have to stay. There's no numbers in the bottom that it's going to cancel out with. My b to the 8th, that's going to stay. There's no b's down at the bottom or the top that can cancel. My c's, though, and my a's. Look at this. I have 2 a's on the top. I have 3 a's on the bottom. That means I'm only going to be left with 1 a on the bottom. Think 2 minus 3, that gives me a negative 1. Pull that down to the bottom. Then my c's, I have a c to the 6th on the bottom and c to the 2nd on the top. Again, I have more on the bottom. How many more? 6 minus 2, I have a total of 4 extra c's, so those are going to stay on the bottom. This is then my final answer. I can't combine anything else, and we've simplified it as far as we can. Let's look over at example B here. Same idea. First of all, look at this term right here. My numerator is being raised to the 0. That's just going to be 1, so we don't have to mess with any of those numbers in there. On the left, though, I have this exponent of 20. I'm going to go ahead and multiply that to each term. So I have x to the 1/4 raised to the 20th, y to the 2/5 raised to the 20th, all over x squared. From here, this is going to reduce pretty nicely for us. we multiply our exponents. 1/4 times 20, or 20 divided by 4 is just x to the 5th. 2/5 times 20, well, think 20 divided by 5 is 4, times that by 2, we're up to 8. So I have y to the 8th. All over, once again, my x squared. And then lastly, we have to reduce this. I have 5 x's on top, and I have 2 x's on the bottom. 5 minus 2 just gives me 3. So I have x cubed, y to the 8th. And that's your final answer, x cubed, y to the 8th. Now let's look at some of these simplifying expressions down on the next set here. Example 2. First thing you want to do is always factor. Factor, factor, factor. So I'm going to start with my numerator. X squared minus 16, that's a difference of perfect squares. It's going to factor to x plus 4, x minus 4. On the bottom, we want to figure out what multiplies to 24 and adds to 10. Well, that's going to be a positive 6 and a positive 4. Now look at what you have. You have an x plus 4 on the top, you have an x plus 4 on the bottom. Those cancel out. I'm just left with x minus 4 on the top and an x plus 6 in the bottom. And that is as far as we can go. I can't cross those x's out. They're being added or subtracted with another term, so we're done. With letter B, we're going to multiply straight across, but if I can start cross-canceling things, I'm going to go ahead and do that. I have a 2 on the top. 2 goes into 2 once, 2 goes into 8 4 times. How about the 9 and 27? 9 goes into 9 once, 9 goes into 27 3 times. Let's go ahead and stop canceling for the moment and just combine that. So I have a 3y squared all over 4y to the 5th. Again, we've got like terms, top and bottom. They're both the base of y. I have 2 y's on top, and I have 5 y's on bottom. So subtract the difference there. There's more on the bottom, so I'm going to end up with 3 over 4 y to the 3rd. 5 minus 2 gives me 3 more in the bottom. Let's try letter C. Letter C here. Again, we want to go ahead and factor first. Again, I have difference of perfect squares. X squared minus 9 is going to be an x plus 3, x minus 3. All over, I can factor the bottom too. Just take out what they have in common. I'm going to take out that x. I'm left with x minus 5. I'm going to go ahead and extend this fraction bar because I'm going to go ahead and multiply the rest of my fraction. I have an x minus 5, just multiplying straight across there. And on the bottom, I can take out a 4. 4x minus 12, they both share a 4. Then I'm left with x minus 3. Again, what can you cancel out? Cross out. I have an x minus 3 on top and bottom. I have an x minus 5 on top and bottom. That's about it for canceling, so all you're left with is x plus 3 on your numerator and a 4x on the denominator. Again, don't cancel those x's, they are different terms. And lastly for these, now I have two rational expressions that are being divided. Let's start with our numerator first. My 3x squared plus 11x minus 4. Well, that's going to factor out to 3x minus 1 times x plus 4. All over on the bottom, the only thing I can take out is an 8x, actually an 8x squared, and you're just left with 3x minus 1. Now instead of division here, I'm going to change that to multiplication. Well, if you change this to multiplication, you need to multiply by the reciprocal, or the opposite of what we have here. So if I change that division to multiplication, my numerator and my denominator are going to flip for what I'm going to multiply this by. So while I flip this, so now my 24x to the 4th minus 36x cubed is going to come to the top. What can I take out of that? Well, they share a 12x cubed. Take that 12x cubed out, you're left with 2x minus 3. Then on the bottom, remember my fraction flipped, so now my numerator is down on the bottom. They share 9 in common. 9 times x plus 4 is going to be that factored form of 9x plus 36. From here, start canceling. Again, this is just one big fraction bar. I'm going to multiply all of this together anyway. So what can I cancel from top and bottom? You should see some common factors. I have a 3x minus 1, 3x minus 1, x plus 4, and an x plus 4. I have a 12 on top and a 9 on the bottom. So 3 goes into both of those. 3 goes into 12 4 times. 3 goes into 9 just once. And then I have on my 8 in the bottom. Sorry, 3 goes into 9 3 times. And then we've got 4 on top. Gonna keep canceling here. 4 goes into 4 once, 4 goes into 8 over here twice. And now let's start combining before we get too clustered with numbers here. On the top, everything was canceling out, and I'm left with an x cubed times 2x minus 3, all over 2 times 3. To multiply those together, we get 6x squared. Now we're not quite done because we left out those x's still. I have 3 x's on top and 2 x's on the bottom. I have 1 more on top, so I'm left with 1x times 2x minus 3, all over just 6. And now we are done with that problem there. All right, go ahead and flip over. We've got one more thing to talk about. Adding or subtracting rational expressions. Now, before I can add or subtract, I need to have a common denominator. Again, you're going to factor first. Factor is going to always help you in problems like this. So I'm going to take my numerator. Can't really do a whole lot with that. It's just a 3x. All over, well, what's on the bottom? I'm going to factor this. Multiplies to 12. Adds to a positive 1. That's positive 4 and negative 3. And I'm adding this now to x over x squared minus 16. Well, that's for a difference of perfect squares. X plus 4, x minus 4. Now look at what they have in common. They both have an x plus 4 already. They have that as part of their common denominator. But my first term does not have an x minus 4, and my second term does not have an x minus 3. So I'm going to go ahead and add those in. This one needs an x minus 3. This guy needs an x minus 4. Okay, from here, now let's see how that's going to make this expand. So I have 3x times x minus 4. And now that I have a common denominator, I can combine these. X times x minus 3 all over that common denominator of x minus 4, x plus 4, and an x minus 3. From here, the last thing you'll be asked to do is just simplify your numerator. You can leave your denominator just as is. So just distribute this out. We've got 3x squared minus 12x plus x squared minus 3x all over your common denominator. And then lastly, go ahead and combine those like terms. I have a 3x squared and a 1x squared. Gives me 4x squared. I have a negative 12x and a negative 3x. That's a negative 15x. All over, again, my common denominator. And again, you don't have to distribute and FOIL all that out. You can just leave it as is. And there's my final answer. And that's it for R5 and R6. Go ahead and try example B on your own and bring that in tomorrow to class.